We're going to look at another one that's a complete the square, but this time when the a term is not 1, this time it's 2. So let's just remember, so in this case a is 2, b is -4, and c is 5. So what we're going to do, first of all, let's just take our function f of x equals 2x squared minus 4x plus 5. And the first thing we're going to do is group the x terms like we do in complete the square. This term and this term, we're going to group it together and we're going to ask this 5 to move over. Okay, and then when we notice in here there's a 2 in common, so we want to factor a 2 out front. So I'm going to take a 2 out. If I take a 2 out of this, I'm going to be left with x squared. If I take a 2 out of this, I have minus 2x. And then I'm just going to carry that down. Now complete the square, we want to know what goes in this box, which we said the box comes from our b term, which we got to use this b term down here, not the original, because we've done some manipulation to it. But we take our b term, which is -2, b term, divide by 2, and square it. So you get -2, divide by 2, and square it. So that's going to be -1 squared is just going to be +1. Well, I put +1 here. On the last problem, if I put a +1 here, then I subtracted a +1. But in this problem, when we had to factor a 2 out, this really is 2 times 1. So if we're just adding 2 in, we have to subtract the 2 out over here. And that's the difference between when a is 1 and when a is not equal to 1. You have to consider this in. So now let's simplify it. So I'm going to have f of x is equal to 2x squared minus 2x plus 1. And then 5 minus 2 is plus 3. Now we want to do bottoms up here, or we can use our shortcut, which is variable of the first, sine of the second, square root of this term in the box. The square root of 1 is 1. Put it in parentheses and square it, and carry this down. So we would have our vertex form of this parabola is going to be this, and our vertex is opposite, same. So our vertex is going to be 1, 3. From knowing our vertex, we like to use the vertex in our points. And we'll put a note by this, and we'll say let's do a number to the left of 1, which is 0, and a number to the right of 1, which would be 2, and then maybe one more for good measure. Okay, so now I'm going to erase all of this previous work and take my original function and substitute values in. And so everywhere there is an x, I put a parenthesis, and then for my first one I'm going to plug in 0. If you plug in 0, you would get 0 here, 0 here, and you would just get 5. We're going to do the same thing with a 2. I'm going to pause it and do 2. Alright, check your work. You can see that if you plugged in 2, you would get the ordered pair 2, 5. And one more time with 3. Check your work with x equals 3. We should get the order pair 3, 11. And now we'll transfer these order pairs to the graph and name domain and range. So we'll start with 0, 5, 1, 3, 2, 5, and 3, 11 is somewhere up here. So our parabola looks like that. The domain is going to be the x values left to right, -infinity to +infinity. And the range is going to be starting from the bottom to the top, the bottommost y value, which is a 3, to infinity. Alright, so we learn our last methods. We have vertex formulas and of quadratic functions. with if you have a regular vertex form, which we've been working out, we said the vertex was HK. Okay, if it's not in that format, then we would have to use complete the square, which is the last two methods, and we don't really favor those that much. Or we can use this idea right here, which I'm going to show you in just a second. We'll evaluate it. Basically, you take your vertex in general form, you name your A is 1, B is -10, and C is 21. And we're going to use this formula, negative b over 2a. So the x value is going to be negative b over 2a. In our particular problem, b is going to be -10 and a is going to be 1. So then a negative times a negative is a positive 10 over 2. So what that tells us in our vertex, that the x value of the vertex is 5. And then to find the y value, just as we've always done in the past, we evaluate the x in our original function. So everywhere there's an x, we want to put a parenthesis, and we're going to plug in a 5, because when the x is 5, we want to plug it in. 5 squared is 25, minus 50 plus 21 would be -4. So this is a very much quicker way than the complete the square for finding the vertex. Now once you find the vertex, we will do the exact same method for picking a point. And I think in my math lab, once you have the vertex, you will only need one other point. But for the sake of time, and we've done this over and over, I'm going to go ahead and plug the points in for you. And then I had 7, 0. So plotting this, I would start with my vertex 5, -4 over 5, down 4, 4, -3, 6, -3, and 7, 0. So we would have our vertex, our parabola, the domain, everything works the same from here. So x values left to right. The range is going to be your y value. So I start on my y-axis, and the bottommost y value is going to be -4. To the topmost, which is arrows, is going to be infinities. And so that's the other method. We're going to do one more of these, and that's going to finish us up. And I almost forgot one thing. The axis of symmetry is going to always be the equations x equals, it will always be this part, x equals, and then whatever the x value of the vertex is. So in this case, the axis of symmetry is just x equals 5. Okay, in this one we have a is -2, b is -12, c is -16. We want to use our formula x equals negative b over 2a. So negative b over 2a. Now we're going to plug in -12 for b, and we're going to plug in -2 for a. So that will give us positive 12 over -4, which is going to be -3. So in my vertex, it's -3, and now I got to plug that value in the original formula for x and see what my y value is. So in my function, -2, everywhere there's an x, I put a parenthesis from this original function right here. Everywhere there's an x, put a parenthesis, and now we're going to substitute that -3 in there and solve. So -3 squared is 9, plus 36 minus 16, so that's -18. 18 minus 16, which will give us a 2. So our vertex is going to be -3, 2. Alright, I'll move all this work out of the way. And we would plot points to figure out the rest using an XY table. Which if I did that, it would be, our table would be like this. Evaluate -4 everywhere x is at, you would get 0. Evaluate -3 for x, you would get 2, so on and so forth. Now let's put them on the graph. Which our parabola would look like that with a vertex of -3, 2. So the domain would be -infinity to +infinity. The range is going to be the bottommost y value, which are arrows pointing down, to the topmost, which is going to be the topmost y value is 2 with a bracket. Axis of symmetry is going to always be x equals whatever the x value of the vertex is. So in this case, x equals 3 is the axis of symmetry. So we talked about 3 different ways to graph parabolas, just by simply plotting points. The second one by complete the square method, and this last method by using our formula up here for vertex and the -b/2a. And that completes our lesson.